Hello everyone, this is Prasanna Patil, working as Assistant Professor in the Department of Computer Science, MIT Mysore. And now we are into the 8th machine learning program, that is KMeans and EM algorithm. And the problem is apply EM algorithm to cluster a set of data stored in a CSV file. Use the same data set for clustering using K-means algorithm. Compare the results of these two algorithms and comment on quality of clustering. You can add Java or Python machine learning library classes or API in the program. So here we are dealing with EM algorithm. EM stands for estimation maximization algorithm, and K-means. K is a number of clusters. Number of clusters by taking the means of data points. And here to cluster a set of data stored in a CSV file, they have given a CSV file, and that CSV file name is Iris dataset. So Iris is a dataset of flower. One second, I'll show you the dataset. Here is Iris setosa, Iris versicolor, then Iris virginica. Okay, so this is regarding the data set, and we have 150 data samples. Setosa 50 data samples, versicolor 50, and virginica 50, totally 150. So what we need to do, we need to cluster this into different categories. So we have 3 categories, so we need to cluster into three categories. Since K-means is unsupervised, we don't need labels for it. We don't need labels to train or to for this K-means algorithm. So we only feed the data sample without any label. So we had 1 2 3 4. Okay, 1 2 3 4. This is the first attribute, second attribute, third attribute, fourth attribute, and the fifth one is the target, that is which type of flower species is it, have given these features. So that feature is, we just look into the feature. The first feature is sepal length in centimeter, and second feature is sepal width in centimeter, and the third one is petal length in centimeter, and the fourth one is petal width in centimeter. The first two are sepal, the second the third and the fourth are petal, and the length and the width, and the classes are here: Iris setosa, versicolor, virginica. Okay, so this is standard data set of a flower set. So whatever the numbers I just showed, those are length in centimeter and width in centimeter. Let's look into the iris flower, petal and sepal. Here it is. See, this the green colored uh, part in the flower is called as sepal, and the colored part other than the green color, if the flower is red colored, then that is petal, and flower is yellow color, that is also a petal. But the green colored in all the flowers are called as sepal. So length and width, what is the length? From here to here is the length. Width means the width of this. So we have 4 features of a flower of 3 types. So what are those? Not 4 features, 2 features. The first one is length and the breadth of petal and sepal. So depending on these 4 criterias, 4 features, we are categorizing a flower as Iris setosa or Iris versicolor or Iris virginica. So this is what the this data set. Now moving to the next, and this is estimation maximization algorithm, and here we have 2 steps. One is the estimation, second one is maximization. Estimating means randomly taking the mean. Okay, first we'll need to know what is a Gaussian distribution, and then Gaussian mixture model, and then what do you mean by taking mean randomly and then maximizing the expectation? Okay, sorry, estimation. How do we maximize the estimation in the second step? So this is regarding EM algorithm. First we look into the K-means algorithm. What is K-means algorithm? It is a unsupervised algorithm. Unsupervised means the data set has no labels. Even we have a label in the data set. We have label, but we don't read this. We don't read this label while we work on this K-means algorithm. Okay, we don't read the label. We just take the all the data without the label. Okay, K-means algorithm. Okay, the sample space is initially partitioned into k clusters. That means we need to provide how many clusters we want, and the observations are randomly assigned to the clusters. That means the observations means the data samples. The data samples are randomly assigned to the clusters. If we make 3 clusters, then the data points are assigned to those 3 clusters based on some observations in the data samples. Okay, for each sample, this is the algorithm we are looking. Okay, for each sample, calculate the distance from the observation to the centroid of the cluster. So distance from the observation, so here we are calculating the distance. Here we are using multiple here we have multiple choices for distance calculation. We choose Euclidean distance. We'll look into it in the next slide. From the observation to the centroid of the clusters. What is the centroid of the cluster? We'll look in the next few slides. If the sample is closest to the own cluster, then leave it, else select the another cluster. Okay. Then repeat the steps. Repeat the steps means for each sample, this is a for loop. For each sample, just try to assign the particular data sample to particular category and make a cluster. So this is what the main K-means algorithm. As I told you, there are many distance calculation formulas we can use here. The first one is Euclidean distance. You already know the formula of Euclidean distance, square root of summation from I to k xi minus y. We can say it as, if we have okay, suppose this is my x and y coordinates, x and y, and this is my point and this is the second point. I call it as I call it as x1 y1 and I call it as x2 y2. Okay, then how do I calculate the distance from this point to this point? So it's a straight line. Okay, how do I calculate the distance from this point to this point? Using the Euclidean distance. What is the Euclidean distance? x1 minus y1 whole square plus, because it's a summation, x2 minus y2 whole square, and we have square root. So this is what Euclidean distance. And if we use Manhattan distance formula, then it's a mod of x1 for the same 2 points, x1 minus y1 plus, because we have the summation, plus mod of x2 minus y2. Okay, this is Manhattan. And the final is Minkowski. Minkowski has a different formula. Again, it is a summation of what? Mod of x1 minus y1, okay, plus x2 minus y2. How it is different from this? Can we cancel this and this? No, we cannot cancel, because this comes inside the summation. Okay, so once we take the square here, and till how many terms we have, then we need to take not square, it is not square, sorry, this is q, we don't know what is the value of q. Then finally, after calculating x1 minus x2, x1 minus y1 to the power q plus x2 minus y2 to the power q, and then finally solving this, then we need to take 1 by q. Okay, this is like square root, right? If we have 2 here, it is a square root. We have q here, we don't know what is the value of q. Depending on the value of q, it can be calculated. So we can use distance formulas. This is for your reference. First one, second one, and third one. Euclidean, Manhattan, Minkowski. Let's have an example of finding the clusters using K-means. So these were the examples, and these data points can be clustered like this. Before applying the K-means, the data points are like this, but after applying K-means algorithm, the data points can be clustered into 3 different categories. As we know, Iris setosa, versicolor, virginica, right? So how do we do this? To do this, we need to know what is K-means algorithm. Then we know what is a K-means algorithm already. The algorithm what I showed before. Choose the number of K clusters. Here I am choosing number of K clusters as 3 or 2, whatever the number I want. And select the random K points. Select the random K points. I need to select the random K points. Random K points means wherever I want I can select the centroids, random K points and the centroids. I mean these random K points are called as the centroids. Okay, and these centroids are not necessarily from your data set. Means if we have random data points, the centroid could be anywhere from here or here. The centroids cannot be like the data point where it lies, right? Means it means we need to take the data points randomly, centroids randomly, irrespective of the data points what we have. Assign each data point to the closest centroid. Then assigning of the data points to the closest centroid, and that forms K clusters, and compute and place the new centroid each cluster and repeat assign again, and finally we have the model ready. Okay, this is just an algorithm, but we need to understand how it works. And okay, choose first step is choose for time being we have taken K is equal to 2 to make computation simpler. We have taken K is equal to 2. If when we take K is equal to 2, how it solves, how the algorithm works on it. So we have taken the data points. Okay, you can see the data points 1 2 3 4 5 6 7 8 9 10. Okay, then the first step is I need to take the centroids first. So I need to randomly take the centroids wherever I want. So these two are the random centroids. So once I take the random centroids randomly anywhere in the graph, this graph, okay, anywhere in this graph, the next step is assigning the data points to the closest centroid. That means whether this data point belong to this centroid or this centroid. Okay, whether this data point belong to this centroid or this centroid. To decide that, I need to find out the distance between this centroid and this data point, and this data point and this centroid. So whichever is nearest, I need to label that data point as that belongs to this blue colored. If okay, that's it. And we need to repeat the same thing for all the data points. So generally what we can say, we just while plotting the graphs to understand it clearly, we can say that take the direct means direct a line, and then put a perpendicular line, 90-degree line to this. Then whichever the data point which lies above this, that belongs to this, and whichever the data point that lies below this, that belongs to this. Okay, this is just a conventional purpose, but actually how it works, the distance between this point and the centroid, and the distance between this point and the centroid, if this point is nearest to this has been considered as blue colored. I mean this data point is belong to this centroid, and this belong to this centroid. See, okay, now I can say that these are all belong to red colored, and these are all belong to blue colored. Next, what is the next step? Next step is, in the before I just took the centroid randomly. What is the meaning of centroid? Centroid is a meaning, if I take a triangle, and I make a centroid over here, right? Centroid means it is equidistant from all these 3 points, right? It is equidistant from all these 3 points. If I make this triangle like this, the centroid, where the centroid will it be in the same point? No, the centroid will move from, if I drag this point like this, and this triangle will become like this, okay, and the centroid will move from this place to this place, so that this can be equidistant from all these 3 points, 1 point, 2 point, and the 3 point. My centroid might be at the wrong place, but what I meant is the centroid is nothing but it should be equidistant, not equidistant, it is the center for all the data points. Yeah, so now what I need to do, I need to make this centroid to the center in the sense, so that it can be available in the same distance. Okay. So how to make this centroid move at a particular location, so that it can be placed somewhere over here. So we have a formula. What formula? We have a formula. Okay, for example I'm telling this is x1 y1, this is x2 y2, this is x3 y3, this is x4 y4, this is x5 y5, this is x6 y6. So centroid also has x and y, correct? So I need to calculate first c of x. What is c of x? Take all the x. There is, how many x are there? x1 to x6, right? So take x1 plus x2 plus x3 plus x4 plus x5 plus x6 divided by how many numbers? Divided by 6 numbers. Okay, so this is cx. What is cy? y1 plus y2 plus y3 plus y4 plus y5 plus y6 divided by 6. So now this becomes cx cy. So this is the centroid. I need to move this center, this point, where exactly it locates, right? Cx is nothing, somewhere here. I don't know exactly, but I can move this from here to here. So this is why I'm moving this from here to here, and for this the red colored, I'm moving this centroid here to here. Once I move this, what I need to do, again do the same thing, again calculate the distance from the data points to centroid. There are only 2 centroids, right? I need to calculate the data point, this data point to this centroid as well as this centroid. If again this point belongs, this is nearest, again if we find this point is nearest to this belongs to this. If this point belongs nearest to this centroid, then this point belongs to this. Okay, and as I discussed earlier, this is what see here, this point belongs to now red color, and this point belongs now, this line is for your convention, okay, for the convention purpose only. Actually what we need to do, we need to calculate the distance using any of those distance formulas. Then this became blue and this became red. Again we need to move the centroid, because the category, the clusters have been changed. Again find out the distances. So this belongs to this, now this belongs to this category, right? So now again move, change, now this belongs to this category, now change, again move the centroids. Now again, now there is no change from previous step to this step, right? Now we need to stop the process. We need to stop the process, and what we need to do, we need to remove the centroids. right? Now two clusters are ready. Irrespective of the labels, we have done clustering of data points into two different categories. Because k is 2, we have taken k is equal to 2. If we would have taken k is equal to 3, we would have made 3 clusters. Okay, that's it. See, only the clusters are moved, not the data points. Data points are uh, at their original position. Okay. Now moving to the estimation maximization, where estimation, it's not expectation, this is estimation. Estimation maximization algorithm. When to use this? We can use it only partially when the data is partially observable, and target value is unobservable, that is unsupervised clustering. Supervised clustering when some instances instance attributes are unobservable. And where we can use we can use in BBN, Bayesian belief networks. So this is your 7th lab program, Bayesian belief networks and unsupervised clustering, and learning the hidden Markov models. Hidden Markov models, HMM. This is now generating data from mixture of k Gaussians. What is a Gaussian now? Gaussian distribution is used to represent an object. That means whenever in the image, if we consider an image and each and every object in the image is represented with a Gaussian distribution with some formula of Gaussian. If you have gone through the digital image processing, you might have learned what is you might have heard what is Gaussian distribution, and that is bell shaped, right? Bell shaped distribution. So if there is an object, the distribution will go up and down, the bell shaped distribution. Okay, but what is it about? Generating data from mixture of Gaussian distribution. What is a mixture of Gaussian distribution? For a single object there will be one Gaussian distribution, but for multiple objects there are multiple Gaussian distributions. For example, if there are two objects, object number 1, this is object number 1 and this is object number 2, if both are different, then we have two different Gaussians. But if both the objects are overlapped or somewhat merged, then the Gaussians of those also merged. Okay, the Gaussians of both the objects will also be merged like this. Then it is very difficult to identify which Gaussian is which object, which Gaussian distribution belongs to which object. Okay, so that's why we go with this. Each instance X generated by choosing one of the k Gaussians with uniform probability, generating an instance at random according to that particular Gaussian. And what is estimation maximization for estimating k-means? So what is given here? The given thing in this here is instances from X generated by mixture of k Gaussian distributions, correct? Instances from X. So X is a data sample. For example, take it as an image, and image has multiple objects. Instances from X generated by mixture of k Gaussian distribution, because there will be multiple objects. That's why we have mixture of Gaussian distributions. And unknown means m1 to mk of k Gaussians. So we will be having unknown means of k Gaussians. If k is 5, then we will be having 5 means. Then don't know which instance xy was generated by which Gaussian. We won't be knowing that which Gaussian is for which object. Okay, so what to determine we need to determine is maximum likelihood estimates of this mean. What is the maximum likelihood estimation for this mean which have been generated by this Gaussian distributions? That is what we need to determine. So think of full description of each instance as, so this is given yi means to label it, we need to look into each and every instance given this. What is zi? Zi is 1 if xi is generated by the jth Gaussian, otherwise it is 0. Okay, that means the probability is more, hence we need to label that particular object into particular class. What is EM algorithm? EM algorithm, it's E step and M step. It's a E step is expected value, calculating expected value by randomly taking the means of the objects, that is h is equal to m1 and m2, and this is what the formula used to calculate the expectation. And then okay, the formula is goes like this. And maximum we need to once we get into this E step, then we need to move to the next M step, calculate the new maximum likelihood hypothesis. We need to calculate the maximum hypothesis. Maximum hypothesis means if there are four different objects, we need to calculate the hypothesis of each and every object, and whichever having the highest probability, that particular Gaussian will belong to that particular object using this formula. Okay, so this is what estimation maximization algorithm. To understand this, we will look into the example. For example, it's a problem statement like some images and their corresponding descriptions. Okay, this is an image, and here we have what we can find. We can find trees over here, and grasses over here, and cherry trees. These are the cherry trees. Cheetah, here is a cheetah, and trunk, this is a trunk, and this is a mountain, and here is the sky. Beach, here is the beach, here the sky, and here are the trees. Here, oh sorry, this is the beach. This is the water. Okay, sorry. Next is this is already given, and if we try to understand what are the different objects present in this, grass, again trees, sky, okay, that's it, and a building over here, and grass, tree trunks, and leaves, cherry trees, and the building, and the grass or trees we can call. Audience, this is a playground, and this is the different segment we can say. Okay, this is how we can describe the images. Okay, now what are the abstract regions over here? I mean, how the regions are classified. This is the original image, and these three are original image 1, original image 2, original image 3, and we can need to convert them into color regions. So color regions, you know how to operate on the image. So here the pixels are somewhat sharp, but the pixels are merged. I mean, the values of the pixels are nearby pixel values are merged together, so that can look nicely, so that we can easily differentiate between the boundaries. Okay, and here also this is very clear, and this is not clear. This looks uniform. So how we approach this? Using some mathematical operations, means nearby values, or else take the mean of everything, and just replace that mean with everything. Clear? replace the mean with all the objects like here, and this is also different. Yeah, this is also different one. Take the mean and like this, clear. And again, texture regions is one more type of finding the different objects. And then finally, once we get to know this, based on this we can differentiate how many different objects are there, how many clusters we can make. This is just an idea of how we can how object model learning can be done. If we look into this image, we can say that this is a sky, this is water, this is boat, this is tree. Anything else other than this? Mostly this is something else, we don't know. Okay, sky, tree, water and the boat. How this can be modeled and trained? So the sky will be trained. See, the sky will be trained like this. All the sky will be trained, and trees will be trained, water will be trained, and boat will be trained, everything. And we have a learned model in this, clear. And how the image labeling is done. Once we have a learned model, we can label the images. So in this image, testing image, how many different classes we have, how many different objects we have. We have a tree, we have a sky, we have a land. Something else we have? No, I don't think I have other than these three. And this is a shadow, but I don't know exactly. Color regions, if we convert it into some other colors, so we got, oh, this is the shadow. So 1 2 3 4. And how do I find out which particular object I have? Means, suppose if I have this tree with me, and if I am finding out whether it is a tree or not with the learned model, so how do I do it? I need to find the probability of that particular object with the whole image, but the whole image has all other objects, this one, this one, this one and this one. Okay, but all those are learned models. If the probability of this with the sky, what is the probability of tree with the sky? It will be lesser. What is the probability of tree with the land? It will be lesser. What is the probability of tree with the shadow? It will be lesser. But what is the probability of tree with the tree? It will be more. Then 1 by 1, that is 1. This will be point, oh, the color is green, blue here. This is 0.2, this is 0.3, this is 0.6. Okay, because the color is similar to this. Okay, so when you get to know that the expectation estimation maximization, according to this, the probability is more, hence the particular object is a tree. Okay, this is how the things work based on the object model database what we have trained, right? This is regarding the estimation maximization algorithm. And here we need to look into, before going to the program, we need to look into the modules we have used in this program. The modules we have used in this program are okay, sklearn. In sklearn, the first thing is under sklearn, the first subclass or submodule is data sets. Remember the spelling with its case, whether it is uppercase or lowercase. All the letters are lowercase, small case here. Okay, and second is metrics, METRICS. Third is cluster, the fourth is cluster K-means, the fourth is mixture. Okay, and how can I use these submodules? Using sklearn dot datasets, sklearn dot metrics, sklearn dot cluster, sklearn dot mixture. But this is from sklearn dot datasets. Import what? From the dataset I need to import the dataset. Iris, not iris, it's load iris. This is not a function, okay? Don't write the function over here, okay? This is just iris. Yeah, and import matrix import. There are two things we can. No, I don't think so. Okay, import sklearn from sklearn dot matrix. This is not. Okay, this is sklearn from sklearn import matrix as sm. Okay, sm means sklearn matrix. You can use this object as this alias as sm dot accuracy score. We have two parameters, and sm dot confusion matrix. Again, confusion matrix. We need to input two things. I think so. Okay, we have two arguments. Then cluster. From sklearn dot cluster we need to import what? Import clustering. What is a clustering algorithm? Which is a clustering algorithm? We just discussed unsupervised clustering algorithm, that is K-means. So K-means. So K and M are uppercase and all other things are lowercase. And the mixture is from sklearn dot mixture import. So what I need to import from mixture? So I just told you the Gaussian mixture model, right? So mixture, one is K-means, one is Gaussian. So import GMM. Okay, GMM. If GMM will not, if it doesn't work, you need to type the full thing. Gaussian, G capital, GAUSSIAN, Gaussian mixture. G capital and M capital. Okay, only Gaussian mixture, not model. So this is what you need to know before you type a program or write a program. Okay, then now we'll look into the discard, keep. Let's see what happens. Okay, we have this. We just clear it and run it once again. Remove, yes, clear. and we are into spider, and I have already discussed about the load iris. Okay, one more thing I forgot is I need to tell you what is Matplotlib, right? So this is not M is small, M-A-T plot lib, matplot library. Okay, Matplotlib. Don't get confused of these modules, just read them as they are. Matplotlib. So Matplotlib has pyplot. So what we are doing here, from matplotlib.pyplot import what? Not from, import matplotlib.pyplot as PLT. Correct. After importing the PLT, what we are doing, we are using this PLT, that is alias for Matplotlib, as PLT dot, the first thing we used subplot 3 arguments. Okay, and PLT dot title it accepts a string, and PLT dot scatter or plot. Okay, scatter has x comma y comma color map, and the subplot has it takes 3 arguments. First one is the row, second one is column, third one is which part of this row. Okay, for example, if I take 1 2, that means row is 1. Okay, row is 1, the row is 1. Okay, and the columns are 2, 1 row and 2 columns, 1 2, and I need to specify which partition I need to take. If I specify 1 here, the plot will be displayed over here. Okay, displayed over here. If I if I change this to 2, then the plot will be displayed over here. Clear? So this is subplot 1 2. In while drawing the k-means, we use 1 2 2, right? While drawing estimation maximization, one second, sorry, this is 1. While drawing, I don't know, but while drawing you can plot it anywhere you want, but if you are drawing it 1 and you need to give it k-means, if you are drawing it here 2 respective plot, you need to give 1 2 2, then title should be below this. Okay, em. This is regarding Matplotlib, and we are using pandas also, and numpy also. You know why do we use pandas? We just use the pandas to read the Excel sheet, and here there is no Excel sheet, but we can use this pandas to read the data set, that is iris. Right? So once we download we have already downloaded the iris dataset. We have already downloaded the iris dataset through the sklearn.dataset, imported iris, load iris, and that's why we are using this and load iris. Okay, we have imported this load iris, and this both are different. This is a class and this is a constructor. Okay, it ends with a parenthesis, correct? This is a constructor, so everything loads into the iris. Then what I need to do, I need to use the pandas PD. What is PD? PD is a panda. I need to use this pandas and use the data frame of the pandas to read the iris.data and iris.target. So what is iris.data? This is iris.data, means from here to here, sorry, from here to here, except this labels, it is iris.data. Okay, I'm putting all this data into X using the pandas data frame, and I'm putting all these targets, whatever the targets from 0 to 150 149, 0 to 149, I'm just copying everything into the target, the Y. Okay, iris dot target. Here we are not reading any file externally. We are not reading any file externally because we are loading it online. It has already been loaded, imported into the system. It has been downloaded. You are just using it. Okay, and how you are using it in the program? By importing it. Okay, then color map. We need to color. We need, if whenever we are showing we are showing the graph, we need to color it to represent the different categories of the data. So what we are taking, red, blue and green. And np.array, array is a method always starts with what? Always starts with a parenthesis, right, and ends with a parenthesis. And inside this array we are passing an argument which is a list, and that list contains 3 different elements. One is red, blue and green. Remember this, don't make any mistake in this. Next is everything is done. We have segregated X and Y. And now what I need to do, I need to use the KMeans class to work on the data, that is unlabeled data. Okay, so how do I do it? How do I do this? It is very simple. You can use this sklearn matrix later also, but now we need to start from here. From sklearn.cluster import KMeans. KMeans, KM is K and M both are capital here, and in cluster none of the alphabets are uppercase, all are in small case. And how do I do this? How do I get to know that it's a smaller? If I press sklearn dot then tab, press tab and then press C. If you press C, all the modules which starts with C will be listed, and we have C here. Okay, you can just press enter. But when you do this, and if you type C, capital C, none of the modules will be listed. That means none of the modules starts with capital C. So you need to check with 2 things, capital and the small, if the module doesn't work. Okay, and then we have imported this KMeans. And why do we need this KMeans? To call we have imported the KMeans and use the constructor. This is a KMeans constructor. What we are passing? We are passing n underscore clusters. So n underscore clusters, 1 second. See here, if you press inside the parenthesis, if you press shift plus tab, it will tell you what parameters it can take. If you press shift plus tab, it will tell you what parameters it can take. So here KMeans taking self n underscore clusters. So if you don't remember what it is, what we need to pass as an argument to the KMeans, then just press shift tab. You will get to know what are the different parameters a method is taking. That's it, and you can type it if you want. Okay, this is constructor in dot fit. Dot fit means we are training with the training set that is unlabeled. So whatever we train, that will be that will be modeled into this k-means. Okay, k-mean, this k-means, that k-means is different. So if I take it as km, that would be better. Km is a object, k-means is a class name, okay, or a constructor name. So km, then plot plt dot subplot 122. 122 means we are just plotting it in the second subpart. Then plt dot title, k means scatter x2. What is x2, x3? x2, x3 are this one is x0, this one is x1, this one is x2, this one is x3. So we are considering the sepal length and sepal width, not the petal length and petal width. Okay, based on the sepal length and sepal width, we are just training the model. Scatter, and then color maps, whatever we have used, we can do the same thing over here. Then what else? Okay, k-means dot labels, I need to change this to km because I have renamed it, right? I have created already an object km, so km dot labels. It has okay, once I run, I'll just show you how to get to know this. Okay, accuracy. So accuracy is y is, what is y is actual, what is the value, what is the label of a particular data sample. What is k-means dot labels? K-means dot label is what we have predicted, means what we have learned and what we have predicted. Okay, that is accuracy score. Then confusion matrix. What is the confusion matrix? Confusion matrix, I'll just show you, one second. This is regarding k-means, and then we move to the EM algorithm, which is nothing but Gaussian mixture module. From sklearn.mixture import gmm. If gmm will not work, then you need to replace it with Gaussian mixture. Okay, you need to replace gmm. If it gives you the error like no modules found gmm, then you need to replace gmm with Gaussian mixture, because it is it might not, the version might not be supporting or something else, right? The module name will keep on changing when as they keep on updating the programming things, right? Okay. Then in the same way, how I created object, you need to create an object for Gaussian also. gmm, this is a constructor, this is a class. gmm, it takes n components. If you want to know what parameters it takes, just press shift tab. Then these are the difference here. This is n components and this is n clusters, right? If you get confused between these two, then you can press shift tab in the spider, you'll get to know. So is equal to 3, then fit, this will be the fitted model. And here you may got a question, you might have come across a question or a doubt like why we predicted here, why not we predicted here, right? We can predict also here, like for example, see, we can also predict over here. K-means, not k-means, it's a km. Using this object what we have created, we can also predict it. But prediction, what we're doing, we are just taking x is unlabeled data, and here also gm.predict, again it is taking unlabeled data. Okay, and this is the model which has been trained, and this is the model which has been trained, correct? Then what is the use of this? What is the use of creating this? Instead of k-means.labels, km.labels, we can take we can replace this with km cluster. Clear? Instead of km.label underscore, if we have predicted, we can replace this particular thing with this, and this particular thing with and this is it, and we are just plotting this EM graph on the first part, and this is the color map, and everything is similar, and this is accuracy, and this here, this is the Y cluster, this is the Y cluster what we have just built the model, and this is also Y cluster for the confusion matrix. If we run this, okay, we got the same output, even though we have we have used different, we have just modified the code. Okay, here, okay, one second. I'm increasing the font. K-means accuracy is 89%, and the confusion matrix for K-means is this. What is the confusion matrix? Confusion matrix is nothing but we have three different categories here. So first row is Iris setosa, second row is confusion matrix is like this. 50, oh, there is no comma. 50, 0, 0, 0, 48, 2, 0, 14, 36. Okay, how many data samples are in data set? 150. So if you add all these values, you'll get 150. That means the different categories of flowers are distributed and not distributed, correctly classified and misclassified into different categories. So how? I'll tell you. This is first row, this is second row, this is third row. This is setosa, this is versinica, this is versicolor, whatever, okay, or vice versa. So setosa, there are 50 setosa, correct? All the three different categories of flowers are distributed into 50, 50, 50. Out of 50 setosa, the first one are correctly classified. First, 50 flowers are classified correctly as Iris setosa. Means none of the flowers are wrongly classified as Iris versicolor or Iris virginica. Okay. Next, versicolor. So 48 versicolor are correctly classified, and none of the versicolor are wrongly classified as setosa, and only two of the flowers are wrongly classified as virginica. Understood? Okay. The third one, virginica, correctly classified 36. 36 flowers are correctly classified as virginica, but 14 are wrongly classified as versicolor, and 0 are wrongly classified as versicolor. So this is what confusion matrix. Looking into the confusion matrix, we can come to a conclusion that this is what the classification we need to. This is what the classification of the data samples has been done according to the algorithms what we have worked on. So this is regarding it, and the accuracy of EM algorithm is 86.6. When I run this same algorithm using a Gaussian mixture, it gave me 95%, but when I use GMM, it is giving 86%. Okay, confusion matrix for this. Again, if you add all this, you'll get 150. Okay, and this is a graph. This is a graph where we have categorized 150 datasets into datasets into 3 clusters using K-means as well as EM algorithm. And one more thing, if I take this cluster as 4, what will happen? If I take the number of clusters into 4, what will happen? Can anybody guess? Okay, keep your guess with you, and I'll just run this and say what was your guess, right or wrong? Oh, it got error. What is the error? See here, we are clustering into 4 and we have labeled it only with the 3 colors. So what we need to do, we need to add one more color, yellow. And if we run this, we got output. See here, 4 colors: blue, yellow, green, and the red. So this is K-means. I have changed only with the K-means. Okay, I have changed the value of K-means. That's why I have got with the 4 different colors. Got it? And what about the this confusion matrix? Even the confusion matrix also got changed because it is 4 colors. That means 4 clusters. This is 4 cross 4 now. If you change, if cluster is equal to 10, this will become 10 cross 10, and there will be 10 colors, different colors, but we need to specify 10 different colors. I hope you understood, and if you can do the same with the EM algorithm also. And that's it. So yeah, okay, that's it. Thank you guys.